Alright guys, learning target 2 is going to be solve linear equations. This video is going to be a little longer, so make sure you're prepared for that. There's lots of notes here in the first 5 steps to solving linear equations. Feel free to pause the video and get down everything I write down. Everything that is on this video should be written down in your notes, and I'll be checking for that when we check notes. Alright, let's get started with the 5 steps to solving an equation. Okay, so you have 5 columns here. Just add in each column what I write in each slide. The first step, and a lot of you should know this, is the distributive property to eliminate parentheses. We're going to use the distributive property, or we're going to distribute to get rid of parentheses if we have them in an equation. So to do that, we might have an equation. This is an expression, but we might have an equation something like this. Okay, this step to get rid of the parentheses, to do that we're going to distribute. So we're going to take 3 times x, and I like to do this with 2 little swoops, like I said in the last video. 2 little swoops of multiplication. So we're going to take 3 times x, which gives us 3x, and then 3 times 4, which gives us 12, and that's a plus sign in the middle, so we'd have 3x plus 12 equals 16. So that's step 1. Okay. Step 2 is to combine like terms on both sides. Some equations you might have both sides of 2 expressions to combine, or sometimes you only have one side. Sometimes you'll have to combine things that have an x, so 2 coefficients. Sometimes you'll have to combine constants. So in this example, we have to combine 2x and 3x. They both have x's, so we can combine those. They're both positive to be 5x's. 2x plus 3x is 5x's, so we would simplify that. 5x plus 4 equals 20. Now maybe this was the equation. Instead of 2x plus 4, it was 2x plus 4 minus 5 equals 20. Okay? There, our like terms are just the constants, and so we can combine those again. A positive 4 and a negative 5. We'd have 2x minus 1 equals 20. Alright, so that's step 2. Step 3 is to make sure the variable is only on one side. Okay, if we have a variable on both sides, we need to move one of them over, or move the other one onto the other side to be able to solve the problem. Okay, I like to draw a line down from my equal sign so I know where my equation balance is. The way we do this is we get rid of the smaller x. So if we have 6x plus 4 equals 12x, I'm going to get rid of the smaller x, so I'm going to subtract it from both sides. And then I have 4 is equal to 12x minus 6x is 6x. Okay? Sometimes you'll have negative x's. So let's say I had something like 15x plus, no, let's do 5x. 5x plus 3 equals negative 3x plus 6. Okay? Notice here that negative 3 is smaller than a positive 5.
Mayra Andrews to the office, please. Mayra Andrews to the office.
Negative 3 is smaller than 5. So to get rid of this negative 3x, I'm going to add 3x to both sides. So I'd have 5x plus 3x, and that would give me 8x plus 3 equals 6. And I'd continue with the next step. So sometimes you have to do the opposite and add an x to get rid of it. Step number 4 is to eliminate the constant term. The constant term is the term that's on the same side as x, but it doesn't actually have the x with it. So if we go back and we look in these examples, here the constant term would be 3. Here the constant term would be 4. Here the constant term would be 4 as well. Here the constant term would be negative 1. And there the constant term would be 12. Okay, so it's that constant term. It's that whole number, basically. So we're going to remove that by either adding or subtracting. So in this case, I would subtract 7 from both sides of my equation. And I'd have 3x equals 12. I might have to add 7. So if this was 3x minus 7 equals 19, I would have to add 7 to get rid of it. So I could add 7 to both sides. And I'd have 3x equals 26. All right. Then my final step is to eliminate the coefficient. The coefficient is the number that is multiplied or divided by x. All right. So if we go back here, the coefficient is 3. If we go back more, the coefficient is 6, or here the coefficient is 8. If we go back even further, here the coefficient is 5, here the coefficient is 2. If we go back here, here the coefficient is 3. All right, so you'll have a coefficient. If there is no coefficient, then it's probably 1, because there's just one x. To get rid of that, we either multiply or divide. All right, so 3 times x, to do the opposite of that, I'm going to divide by 3 on both sides, and x is going to be equal to 4. If my equation is written like something like this, where x is already divided by 3, then my coefficient is actually 1/3, because that's 1/3 times x. It's just written as x over 3 because there's only one x on top. So to get rid of that, I'm going to multiply by 3 on both sides, or that's the same thing as multiplying by 3 over 1. So if I did that, then 3 divided by 3 is 1x, and 12 times 3 is going to be 36. All right? I might also have something like 2/3 x is equal to 4. All right? If I have 2/3, then to get rid of my 2/3, that's my coefficient, I'm going to multiply by 3/2, because then my 2's will cancel over here and my 3's will cancel over here. But if I do it to this side, I have to do it to this side. So I'm going to multiply by 3/2, and then x would equal 4 times 3 is 12 divided by 2 is 6. All right? So those are my 5 steps. Make sure you have all of those notes on your note sheet there. And let's start in with some problems. So if I'm going to solve this equation, first thing I'm going to do is draw my line down. There are no parentheses, so I don't have to add or to get rid of parentheses. I don't have to combine like terms because my like terms are on opposite sides. So I have nothing to combine over here and I have nothing to combine over here. What I do need to do first is get x to one side. I notice that I have a 5x and I have a negative 6x. Negative 6 is smaller than 5, so I'm going to add 6x to both sides. When I add 6x to both sides, I get 11x minus 6, and then these cancel because that's 0, is equal to 16. All right? Now I'm going to add my constant, so I'm going to add 6 to both sides, and I'm going to have that cancel, and 11x will be equal to 22. I'm going to then divide by my coefficient, divide by 11, and x will be equal to 2. All right? I could check that by saying, okay, 5 times 2 is 10, minus 6 is 4. Does that equal negative 6 times 2? Well, that's negative 12 plus 16. That's also 4. So I can always go back and check. Another thing we want to talk about is the justification for our answers. So how did we justify what we did? Well, in my first steps, I used the property of equality, the additional property of equality, to combine like terms. Okay, I knew that I could add 6x and 5x because they're the same term. Then I used the additional property of equality to combine like terms. Again, when I added the 6, then I used the division property of equality, knowing that if I divide both sides by 11, I'll get 2. All right, let's try another one. Here we're going to use the first step to remove these parentheses. So I'm going to rewrite my 4x, and then I'm going to distribute this 8. You may notice that there's a negative sign in front of the 8. So if you like to, just go ahead and add a negative so that you remember that that 8 is a negative 8 because of that subtraction. So negative 8 times x is going to give us negative 8x, and negative 8 times 1 is going to give us just negative 8. And we have equal to 8. So then I'm going to go ahead and draw my line down. I notice that I need to combine like terms. I have 4x and I have a negative 8x. Together, that is a negative 4x. So negative 4x minus 8 is going to equal 8. I need to get rid of my constant term, so I add 8 to both sides. Then I have that cancel, and I have negative 4x is equal to 16. And then I'm going to divide by a negative 4. And I have x is equal to 16 divided by a negative 4 is going to be a negative 4. So let's look at the justification for those steps. First, I used the distributive property. Then I combined like terms. Then I added my 8 to both sides, so I used the additional property of equality. And then I divided using division property of equality. Here we have a case where we have a coefficient that's a fraction. So it's going to look very similar. I'm going to draw my line down. I don't need to have parentheses. I don't need to combine like terms. I don't need to get x on one side. So I'm going to go straight to getting rid of my constant. So I'm going to add 3. And so then that's going to cancel. I'm going to have 8, or x divided by 3 is equal to 18. So now, to get rid of my 3, this is x divided by 3, or it's 1/3 times x. To get rid of it, I'm going to multiply by 3 on both sides. And 3 divided by 3 is just 1x. And 18 times 3 is going to give me 54. So that's my x. All right. Here we get into even a more complicated one with a coefficient fraction. Same thing. Draw my line down, get rid of my constant. So I have 2/5 x equals, now 12 minus 4 is going to give me 8. All right. And then now to get rid of my 2/5, I'm going to take and multiply by 5/2, because 5 divided by 5 is 1, 2 divided by 2 is 1. If I do it over here, I have to do it over here, so I'm going to multiply by 5/2, and I have x equals 8 times 5 would give me 40, and then if I divide by 2, I have x equals 20. All right. Special cases. There are some circumstances where you're going to run into some things, and one of these was on the pretest, that don't really make sense. All right, so let's go through these two equations and see what happens. On this first one here, I'm going to draw my line down. I'm going to distribute with 2 swoops of multiplication. So 2 times x is 2x, 2 times 4 is 8, minus 5 equals 2x plus 3. Then I'm going to combine like terms, so I'm going to have 2x plus 3 equals 2x plus 3. Now you might hear it that I just said the same thing. And it looks like the same thing on both sides. And if we continue to solve, well actually that wouldn't be the first step. Our next step would be to get x on one side. I need to get rid of 2x minus 2x. And both of these go away. 2x minus 2x is 0, 2x minus 2x is 0. And I have 3 equals 3, which is true. Okay? So what is the case? I mean, what could x be? If I go back to where I have 2x plus 3 equals 2x plus 3. If I get rid of the 3's, then you'll see I have 2x equals 2x. If I divide by 2, then I have x equals x. So what can x be? Could x be 1? Well, 1 times 2 is 2 plus 3 is 5. 1 times 2 is 2 plus 3 is 5. Could x be 4? 2 times 4 is 8 plus 3 is 11. 2 times 4 is 8 plus 3 is 11. And even if I go back up here and I put in, let's say I put in 1 again, I'm going to have 1 plus 4 is 5 times 2 is 10 minus 5 is 5. And if I put in 1 here, I'm going to have 2 times 1 is 1 plus 3 is 5. So 5 equals 5. What happens here when x equals x, or when 3 equals 3, or when 2x equals 2x, or when 2x plus 3 equals 2x plus 3, when both sides of the equation are the same thing, x can be anything. So we're going to have infinite solutions. All right? X could be anything. X could be 542. X could be infinity. X could be 0. X could be negative 600. It could be anything, and both sides of those equations would balance. So let's move on over here. Over here, if I draw my line down, I'm going to add like terms. So I have 3m plus 1 equals 3m plus 9. Now notice here, I have 3m and 3m, but then I have 1 and 9. So what happens when I subtract my 3m's? Then I just get 1 equals 9, which isn't true, right? And if I go back here and I get rid of my 1, maybe first, then I have 3m equals 3m plus 8. Well, what if m was 1? Then 3 equals 3 plus 8. That's not going to be true. There's nothing that will make this true. So whenever you have the same thing and different constants, the same coefficient and different constants, there is going to be no solutions. All right, so those are two special cases, and you'll see more of those in class. For us, before class, I'd like you to write an equation. So don't solve it. Oh, actually, do solve it, sorry. Write an equation here on your paper. So write an equation on one side, and then do the work and solve it over here on the other side. What you're going to do is you're going to give your equation to your partner when we get to class, and then you're going to check their answers. So you can try to make it really difficult. You can try to make it a little easier. You can do whatever you want and bring that to class.